In your GCSE exam or any exam for that matter, you may encounter this kind of decimal numbers and you'll be asked to convert it into fractions. Many students find it difficult to do this. However, in this video, I'm going to teach you easy ways to convert these recurring decimals, as they are called, into fractions. So let's do this. Okay, so we are here. So like I told you, we have three types of recurring decimals. So this is the first one, which is the type 1. It's called the pure recurring decimal. And the reason why it's called pure recurring decimal is because everything repeats immediately. So we have some example here. We have the first example, which is 0.777 ... Now when you see ... it simply means that it continues 77777 like that. The second one is 0.333 like that, and then we have 0.1212121212 like that. Okay, so let us start with the first one. So let me write my solution here. Okay, so the first one is 0.777. Now our aim in solving this is to ensure, you can see this 0 right here, right? We don't want that. We want something that is a whole number there and not 0. And for us to be able to achieve that, we have to move these points somewhere here so that we have 7.777 ... like that. And one way we can do that is to multiply it by 10. So when we multiply 0.777 ... by 10, we'll have 7.777 ... But before we do that, we'll have to say that let x be equal to 0.777 ... So then 10x will now be equal to, that's 10 times this, will now give us 7.777 ... So that's what we have. So we have succeeded in bringing a whole number here, which is what we wanted. So that has been achieved. Now the next thing we want to do is to subtract x from 10x. So that is 10x minus x. So we know that 10x is this. So that is 7.777 and so on and so forth, minus x itself, which is this one here, 0.777. Now 10 minus x will give me 9x. So 9x will be equal to 7.777 minus 0.777, which will just give me 7. So this implies that when we divide both sides by 9, so that x will stand alone, we have that x is equal to 7/9. So you see that the same x that is 0.777 is now the same x that is 7/9. So what does that tell us? That tells us that 7/9 is equal to 0.777 in form of fraction. So we have succeeded in converting 0.777 to fraction. All right, so the third one is 0.1212. So if you look at this, you see that this recurring decimal is different. And the reason why it's different is that if you look at this, the first two, it has just one number recurring. Okay, so for the first one, 7 is recurring. For the second one, 3 is recurring. But for the third one here, two numbers are recurring. That is 1 and 2. 1, 2, 1, 2, 1, 2. So that helps us to understand something, that for this question right here, instead of multiplying by 10 so that the points will be here, we multiply by 100, because we are trying to move the points to a place whereby there is no longer surprises. Let me put it that way. There's no longer surprises. That means the recurring decimal is predictable. And so when we see this is 1, 2, we know that the next is 1, 2 again, and next is 1, 2. So it has to be somewhere here, so that where we know that the repetition has stopped. So that means we have to multiply by 100, 1, 2 like this. So let us go back. So that means that, so like the same procedure, let x be equal to 0.1212. Okay, so 100x is now equal to 12.1212. Okay, you see the point? So that's it. So what does this tell us? That tells us that 100x minus x is equal to 12.1212 minus 0.1212. So 100 minus x is 99x, and this will give me 12. Okay, so when I divide both sides by 99, I have x to be equal to 12 over 99. And I believe I can break this further because 3 can go into 12 4 times and 3 can go into 9 33 times. So we have x to be 4 over 33. All right, and 4 over 33 is the same thing as 12. Oh, sorry, is the same thing as 0.1212 dot dot dot. So you can always check with your calculator to find out if all that we have been doing is correct. But there is something that I want you to understand in what you have done so far. There is a pattern that has appeared. That pattern is that if it has one repeating digit, then it is over 9. But if it has 2 repeating digits, then it is over 99. Okay, yeah, so that's it. All right, so we are on to the second type of recurring decimal, and this one is called mixed recurring decimal. And the reason why it's called mixed recurring decimal is because the digits in the decimal place are mixed. So we have this first one that is not so mixed. It's just 1.2222, which I believe we did something similar to this in type 1. And then we have this that is a little bit mixed, which is 0.3455. So how do we tackle these two? So we have 0.1222 dot dot dot. All right, so in this case, because we have 2 digits and then it begins to repeat, that means we have to multiply 2 times. So multiplying twice, first of all, we have to let x to be equal to 0.1222 dot dot dot. So we multiply twice. And when we multiply twice, we have 10x to be equal to 1.222 dot dot dot. And then we have 100x, which is 12.222. The reason why we had to multiply 2 times is so that we can have a consistent decimal repeating or consistent recurring decimal right here. We have to be very sure that the decimal is recurring. We have to now subtract. So 100x minus 10x will be equal to 12.222 minus 1.222. Over here we have 90x, and 12.222 minus this is 11. So when we divide both sides by 90, we have 90 over x. That's 90x over 90 equal to 11 over 90. So we have x to be equal to 11 over 90, which is the same thing as 0.1222. So you can check it with your calculator to find out if that is what we really have. All right, so let's move on to the next one. The next one is 0.34555. So we're also going to multiply, but can you guess the number of times we are to multiply this one? So let me just give you a little second. So what do you think? How many times? All right, if you said multiply 3 times, you're correct. So that means we have to multiply 3 times. First of all, let x be equal to 0.34555. So 10x is equal to 3.4555, and then 100x is 34.555, and then 1000x is 345.555. So this is what we have. So whenever we're subtracting, you always subtract the last 2. Okay, so you subtract this and this. All right, so what we have is 1000x minus 100x is equal to 345.555 minus 34.555. Sorry, that's the train. I'm near a train station. So if you do this properly, we will have 900x equal to, what we'll have here is 311. So the next thing we do is to divide both sides by 900. So when we divide both sides by 900, we have 311 over 900. So 900 cancels 900. That leaves us with x equal to 311 over 900. And if you use your calculator to calculate this, you will arrive at 0.3455 dot dot dot. So that's the value of x in fraction form. All right, and now as promised, the type of recurring decimal that students dread the most, and that is the long or the complex repeats. So if you look at these 2 examples here, you will notice that the repetition is long. Sometimes it looks like you can't predict it, but if you're patient enough, you will see that actually there's a repetitive pattern. So we have 0.142857. From here, you will notice that it began to repeat. So this is 142857 again. So how many digits did it take before it started repeating? We have 1, 2, 3, 4, 5, 6. So after the 6th digit, then it began to repeat again. For the second one, we have 0.583583. So from here, it began to repeat. So after 3 digits, this one started repeating itself. So here's what we're going to do. I'm going to solve the first one, and then I'll leave the second one to you. How does that sound? Good. So let's go on with the first one. So solution. So we have 0.142857. 142857. So this is what we got. So because this one is constantly, this one has a one repetitive pattern. It goes all through, then repeats itself all over again. How do we know what we multiply by? We count 1, 2, 3, 4, 5, 6. So after 6 digits, it repeats. So that means we have to multiply by 10 raised to the power of 6, which is, I think, 1 million. So this is what we multiply by. Okay, so that's how we know. So let's go on and do that. So we have that x is equal to 0.142857. So when we multiply x by 1 million, we also have to multiply this by 1 million. And if we multiply it by 1 million, what we'll have is, all right, so that's all we have. So we simply subtract. So what we'll do is to subtract. So we have this is pretty long. All right, so okay, so when we divide both sides by 999,999, what we'll have is x equal. Alright, so when you use your divisibility rule and you break this down to its simplest form, I don't want to take your time. What we have is 1 over 7, because 142857 goes into 99999 7 times. So that will give me my x, and this will be equal to, that is what we have when you do that. Alright, so like I promised from the beginning of the video, I said I was going to give you takeaways, and this is what we have. What are the golden takeaways? The first one is if x is equal to 0.abc, where abc are recurring decimals, then x is equal to abc over 999. Okay, and then the second one is if 2 digits repeat, that's if 2 digits are repeating, that's x is then equal to ab over 99. And then the third one is if 1 digit is repeating, then x is equal to a over 9. So but however, there's something you must take note of, that this is only applicable to numbers in the form 0 plus ab, that's with changes. That is only when these golden takeaways are applicable.